Students, in modern chemical production, chemical equipment is the key to realizing various process operations. For example, in the petrochemical field, crude oil has to be converted into everyday products, such as gasoline and diesel, which relies on the coordinated operation of various chemical equipment. Today, we begin Scenario 6, Learning 6.1, Identification of typical chemical equipment, which is crucial for your future work in the chemical industry. We will learn about chemical plant equipment through a video.
Chemical plants are mainly composed of static equipment and rotating equipment. Static equipment includes pipelines, valves, reactors, columns, vessels, storage tanks, heat exchangers, measuring instruments, and automated production control systems, etc. Rotating equipment includes various pumps, large units, and control valves, etc. We will present various equipment in chemical plants, one by one according to the process flow. First, let's introduce the oil tank farm for storing raw materials, semi-finished products, and finished products. If a chemical plant is compared to the human body, oil tanks are equivalent to the stomach and intestines, which not only transport raw materials to the chemical plant, but also accept chemical products, playing the role of storing raw materials, products, and maintaining material balance. The main types of oil tanks are cylindrical oil tanks and spherical tanks. Common cylindrical oil tanks are used to store atmospheric liquid materials, while spherical tanks store high-pressure liquefied gas materials. Raw materials in the oil tank farm enter the chemical plant through pipelines via basic transportation. Pipelines are connected by pipe fittings such as elbows, reducers, tees, flanges, and gaskets. Pipelines are like human blood vessels running through various equipment to achieve closed transportation of materials. For the convenience of process flow changes and safety, various valves are installed on pipelines, and common valves include gate valves, globe valves, and butterfly valves, etc. The main function of valves is to cut off or connect the pipeline channels of chemical plants to meet the needs of different production conditions. The conveying power of chemical materials is provided by various pumps, which, like the human heart, operate continuously to achieve uninterrupted transportation of chemical materials. There are many types of pumps for conveying liquids, among which centrifugal pumps are representative. After pretreatment, raw materials are sent to the reactor for cracking on the catalyst bed. The cracking products enter the distillation column in the form of a gas-liquid two-phase mixture, and the multi-layer trays of the distillation column provide a place for mass and heat transfer, using the difference in relative volatility of each component in the gas-liquid two-phase mixture. Cutting of different fractions is realized to obtain different target products. The gas phase mixture separated from the top of the column enters the condenser. The condenser is a type of heat exchanger, and its function is to achieve heat transfer between two different media through heat conduction and heat convection. The light components at the top of the column enter the liquid separation storage tank after condensation to achieve liquid-liquid separation and liquid-gas separation. The heavy components in the column are sent to the finished product tank in the oil tank farm through pumps and pipelines to achieve continuous automation of unit operation. A distributed control system, DCS, is often used to realize centralized operation and display, as well as decentralized control and autonomous management. through the remote operation of various control valves by the DCS system. Automatic control of process parameters, such as flow, pressure, temperature, and liquid level can be realized. Today we have introduced the typical equipment of chemical plants. Thank you for watching.
Chemical machinery refers to the machines used for raw material pretreatment in chemical production, as well as the chemical reactions and the product separation processes. First, classification of chemical machinery. Chemical machinery is divided into two major categories: static equipment and dynamic equipment. Static equipment relies on a specific mechanical structure to let materials automatically complete tasks without any moving parts, such as reactors, heat exchangers, separators, and storage tanks. Belong to static equipment. Dynamic equipment, on the other hand, operates by itself and has moving parts, such as pumps, compressors, and fans. You can imagine that those large tanks in a factory that remain motionless, yet conduct material reactions, are most likely static equipment, while pumps that continuously rotate to convey materials are dynamic equipment. Now, let us study some common typical chemical equipment. 1. Electric motor and transmission box. The electric motor converts electrical energy into mechanical energy, and it is composed of components such as a fan cover, stator with windings, squirrel cage rotor, and bearings. The transmission box is responsible for adjusting the motor's speed and torque to values suitable for dynamic equipment. For example, in pump operation, the electric motor provides power, and the transmission box enables the pump to operate at the appropriate speed and torque. 2. Pump. A pump is a machine that transports fluids or increases their pressure. The structure of a centrifugal pump mainly includes a spiral pump casing, an impeller, a pump shaft, a mechanical seal bearings, etc., with a compact and simple design, which meets most pumping tasks. Please first watch the centrifugal pump working video.
A single-stage single-suction centrifugal pump is a type of centrifugal pump powered by an electric motor, which drives the pump shaft and impeller of the centrifugal pump to rotate at high speed through a coupling. The impeller forces the liquid to rotate accordingly, and the liquid is thrown out to the volute in all directions under the action of centrifugal force, and then flows out along the discharge pipe. Due to the fluid being ejected from the center of the impeller, a negative pressure zone is formed at the center of the impeller inlet. The liquid in the container being pumped will be sucked into the pump, and the impeller will continuously suck in and discharge the liquid, thereby achieving continuous liquid transportation. The entire system consists of a steel base, a three-phase asynchronous motor, a diaphragm coupling, and a single-stage, single-suction centrifugal pump. The single-stage, single-suction centrifugal pump is composed of a high-strength steel cast pump casing, a closed impeller with high liquid conveying efficiency, a mechanical seal to prevent medium leakage, a rigid pump shaft, ball bearings, and an immersed bearing box. Single-stage single-suction centrifugal pumps have many advantages such as simple mechanism, easy operation, uniform flow rate, high efficiency, and strong adaptability. They should be suitable for public welfare occasions with small flow rate and high pressure. so they are widely used in various production facilities in the refining industry. Before operating the single-stage, single-suction centrifugal pump, the inlet valve must be fully opened. After completing the pump degassing, the turning should be carried out according to the operating direction. To confirm that it rotates flexibly without any jamming, start the motor with the pump outlet fully closed. After the motor current drops to the minimum value, and the pump outlet pressure rises to the maximum value, slowly open the basic outlet valve, adjust its opening, and control the flow rate required by the device process.
From the video, let us analyze together. Its working principle is the liquid enters the pump through the suction pipe in the rotating shaft. It's accelerated by the rotating impeller onto a circular path. And, under the action of centrifugal force, the liquid flows radially outward from the shaft, enters the spiral volute, and then through the pressure connection discharge pipe, enters the delivery pipeline. Many of the water pumps commonly used to supply high-rise buildings are centrifugal pumps. Reciprocating pump. They are classified by their reciprocating element into piston pumps, plunger pumps, and diaphragm pumps, which are suitable for transporting liquids with small flow rates and high pressure. The structure of a diaphragm reciprocating pump mainly includes a pump cylinder, a reciprocating working element, piston, plunger, or diaphragm, suction valves, discharge valves, and a drive unit, etc. Please first watch the diaphragm reciprocating pump video.
The hydraulic diaphragm reciprocating pump is a hydraulically driven diaphragm-type positive displacement pump. It is composed of a housing bracket, motor, worm, turbine, crankshaft connecting rod, variable speed wheel disc, sliding shaft, chute, flow regulating knob, plunger diaphragm, diaphragm resetter, inlet check valve, outlet check valve, etc. The motor provides energy power and generates hydraulic pressure through the reduction of the worm gear, the change of the motion direction of the crankshaft, and the reciprocating motion of the plunger. The hydraulic pressure pushes the diaphragm to move reciprocally, realizing the transportation of liquid. Due to its advantages of compact structure, safety and reliability, adjustable flow rate, high lift, no leakage and so on, and the ability to transport corrosive, toxic, and high-viscosity liquid media, it is widely used in various chemical plants. The hydraulic diaphragm reciprocating pump is driven directly by the motor through a worm gear reduction mechanism, which converts the vertical rotational torque of the motor into the horizontal rotational torque of the variable speed wheel disc connected to the turbine through the worm gear reduction mechanism. Since the variable speed wheel disc is connected to the crankshaft connecting rod, the crankshaft connecting rod converts the rotational motion into the reciprocating motion of the plunger. The plunger pushes the hydraulic oil to drive the diaphragm to move reciprocally, and the reciprocating motion of the diaphragm realizes the transportation of liquid media. The flow regulating knob changes the eccentricity of the sliding shaft chute in the variable speed wheel disc to adjust the reciprocating stroke of the plunger, thereby changing the reciprocating stroke of the diaphragm. Finally, the precise adjustment of the outlet flow rate of the hydraulic diaphragm reciprocating pump is achieved
through the reciprocating motion of the diaphragm in the pump cylinder. The working volume is changed to transport liquid. Diaphragm reciprocating pumps are especially suitable for transporting highly toxic, radioactive, and corrosive liquids as well as viable liquids and those containing abrasive solids. A compressor is a driven fluid machine that elevates low-pressure gas to high pressure. 3. The reciprocating piston compressor consists of two parts, the main system and the auxiliary system. The main system mainly includes the body, the intermediate part, the transmission component, cylinder assembly, piston assembly, gas valve, and a drive unit, etc. Please first watch the reciprocating piston compressor video.
Reciprocating gas compressors are a type of positive displacement compressor that utilizes an electric motor to drive pistons in reciprocating motion. Compared to other types of compressors, they offer several advantages, including a wide range of delivery pressures, high thermal efficiency, strong adaptability, a broad adjustable range of discharge capacity, mature manufacturing technology, and low cost. Although the flow rate and the pressure they deliver exhibit periodic fluctuations, their ability to achieve outlet pressures exceeding 16 megapascal makes them uniquely suited for hydrogen-related refining and petrochemical applications. The reciprocating gas compressor consists of an electric motor, crankshaft, bearings, crawlsheet, coupling, cylinder, piston rod, piston, gas valve, frame, sealing system, lubrication system, cooling system, and control system. The electric motor of the reciprocating gas compressor converts rotational motion into piston movement via the crankshaft, causing the piston to undergo periodic reciprocating motion within the cylinder. This action makes the working volume formed between the piston and the cylinder periodically expand and contract. When the working volume expands, the gas inside the cylinder expands, causing the pressure to decrease. At this point, the intake valve opens while the exhaust valve closes, allowing gas to be drawn into the cylinder. Conversely, when the working volume contracts, the gas is compressed, leading to increased pressure. The exhaust valve then opens as the intake valve closes, forcing the compressed gas out of the cylinder. Each piston stroke completes a full cycle of expansion, intake, compression, and exhaust, enabling continuous gas delivery through this repetitive process.
During operation, the piston moves reciprocally within the cylinder, causing the volumes of the two working chambers to change, thereby enabling gas intake and exhaust. For example, in natural gas transportation, a compressor is needed to raise the gas pressure. Reciprocating piston compressors have a wide operating pressure range and high compression efficiency, capable of achieving very high pressures. 4. Storage tank. A storage tank is used to store materials, ensuring continuous production. Its structure includes an elliptical head, a cylindrical shell, and various piping and valves. Please watch the storage tank video.
The horizontal storage tank in chemical plants is a long-shaped container for storing various liquid or gaseous materials, with its main structure consisting of elliptical heads at both ends, a cylindrical shell, movable saddle supports, and a manhole. According to process requirements, internal components such as internal ladders, support members, and outlet vortex breakers can be added. The round opening and internal ladder serve as access passages for inspection and maintenance personnel to enter the tank interior. while the support members fix inserted pipes. To prevent impact deformation or fracture, the outlet vortex breaker prevents vortex formation at the discharge port that could entrain gas, thereby avoiding centrifugal pump cavitation. The design capacity of horizontal storage tanks is typically less than 120 cubic meters, featuring capabilities to withstand full vacuum pressure and relatively high positive pressure, providing materials with storage, buffering, and sedimentation space to meet process operation and safety requirements. Horizontal storage tanks are equipped with various auxiliary equipment including temperature gauges, heating coils, pressure control systems, safety valves, and level indicators. Taking aromatic amine compound storage in a horizontal pressure tank as an example. During loading or unloading operations, these auxiliary devices enable real-time monitoring of material level, temperature indication, and pressure control within the tank. When the horizontal storage tank is in the material receiving state, and at this time the pressure control system suddenly fails, the gas inside the tank body becomes compressed, and the pressure continuously rises. When the pressure reaches the maximum working pressure of the storage tank, the safety valve at the tank top automatically activates to relieve pressure, preventing the storage tank from being damaged due to overpressure.
In chemical companies, storage tanks are used to store raw materials, intermediates, and finished products, and the large tanks you see in factories are mainly storage tanks. 5. Reactor. A reactor is used for chemical reactions and mixing of liquids and generally operates in batches. Its structure includes components such as a stirring device and a heating jacket. The stirring device can rapidly mix materials, and the heating jacket can heat or cool the materials using steam or other media. For example, in paint production, various raw materials are mixed and reacted in a reactor. Please watch the reactor video to deepen your understanding of reactors.
The batch-type kettle reactor is composed of a kettle body, kettle cover, jacket heat exchanger, agitator, transmission device, shaft seal device, support, etc. Due to its simple structure and convenient operation, the kettle reactor can meet various process requirements such as sulfidation, hydrogenation, alkylation, polymerization, condensation, and so on, and is suitable for production conditions with small batches, multiple varieties, and long reaction times. Therefore, it is widely used in petrochemical, rubber, pesticide, dye, pharmaceutical, food, and other fields. When putting the batch-type kettle reactor into use, maintain the rotation of the paddle agitator in the kettle. After injecting reaction material and catalyst into the jacket heat exchanger, pass in heating steam to heat reaction material A and catalyst until the required reaction temperature is met. When material B is injected and reacts vigorously with material A in the kettle to release heat, replace the high-temperature steam in the jacket heat exchanger with cooling water. By controlling the heat extraction of the heat exchanger, stabilize the reaction temperature until the reaction ends and the reaction materials are discharged from the kettle. Finally, inject cleaning liquid into the kettle. Replace the cooling water in the jacket heat exchanger with heating steam. Clean the wall-attached materials in the reactor by heating and stirring. And discharge the residual liquid in the kettle. Then, the batch-type kettle reactor can enter the next production cycle.
Six, distillation column. A distillation column is a device for gas-liquid contact, heat transfer, and mass transfer, which achieves separation by utilizing the differences in volatility among the components of a mixture. It works in conjunction with reboilers, condensers, and other equipment. For example, in petroleum distillation, it can separate various products, such as gasoline and kerosene. Please watch the distillation column video to understand its working principle.
The plate distillation column is a tower-type vapor-liquid contact device for separating different components. It consists of equipment such as the tower body, trays, liquid pipes, downcomers, top condenser, top reflux drum, and bottom reboiler. The tower body is divided into a rectifying section, feeding section, and stripping section from top to bottom. In the cylindrical tower body, several trays and downcomers are horizontally arranged at certain intervals. The working principle is to utilize the difference in relative volatility of each component in the gas-liquid mixture through mass and heat transfer on the trays. The light components in the liquid phase are transferred to the gas phase, while the heavy components in the gas phase are transferred to the liquid phase, thus achieving high purity separation of different components. Therefore, plate distillation columns are widely used in the petrochemical industry. The gas-liquid two-phase mixture enters the plate distillation column from the feed tray. The liquid flows through the trays and downcomers of the stripping section to the bottom tray, under the action of gravity. While the gas phase rises through the trays of the rectifying section to the top of the tower. The gas phase, generated by heating the liquid phase in the bottom reboiler, rises through the trays of the stripping section and rectifying section to the tower top. The top cold reflux flows downward through the rectifying section, and its trays and downcomers flow to the tower bottom. On each tray, the liquid phase flows downward, while the gas phase rises through the liquid layer, allowing close contact between the two phases for mass and heat transfer, thus effectively realizing the distillation cutting of different components.
7. Heat exchanger. A heat exchanger transfers heat from a hot fluid to a cold fluid. It is mainly composed of a shell, tube bundle, and tube plates. The two fluids flow separately in the tube side and the shell side, exchanging heat through the tube walls. In thermal power plants, the heat exchanger transfers the heat from steam to cold water, producing hot water for use. Please watch the heat exchanger video to understand its working principle.
The U-tube heat exchanger is a type of shell and tube heat exchanger. It consists of components including a tube box, shell, tube sheet, tube bundle, baffle plates, impingement plate, and supports. The U-shaped double-pass tube bundle has both ends fixed to the same tube sheet. The U-tube heat exchanger also has the advantages of simple structure, low cost, high tube side flow velocity, good heat transfer performance, strong pressure bearing capacity, and easy cleaning of the shell side. The U-shaped ends of the tube bundle can expand and contract freely, giving it excellent performance in resisting thermal stress and achieving thermal compensation. Therefore, it is widely used in petroleum refining and chemical industries. For processes with large temperature differences between tubes and shell side media prone to fouling, high temperature, high pressure, and strong corrosiveness. The operating principle for U-tube heat exchangers is to first start the cold flow, then start the hot flow. The cold flow enters the lower tube box through the lower inlet of the channel head, passes through the U-tube bundle, collects in the upper tube box, and then exits through the upper outlet of the channel head. The hot flow enters the shell side through the upper inlet of the shell, is evenly distributed by the impingement plate, and then vertically scours the tube bundle under the guidance of baffle plates. The hot flow and cold flow adopt a counter-current arrangement, achieving heat transfer through both conduction and convection. The cold flow absorbs heat and its temperature rises, while the hot flow releases heat and its temperature decreases. The U-tube bundle heat exchanger fulfills the requirements of energy recovery and process medium temperature regulation through thermal energy exchange.
The diagram shows a reactor. Please discuss, based on what you have learned, how it heats or cools the liquid materials inside the reactor. 8. Filtration equipment. Filtration equipment can separate liquids and solids in suspensions and is divided into batch filters and continuous filters. Plate frame filter presses are batch type and are composed of filter plates and frames. Please watch the plate frame filter press video to understand its working principle.
Plate and frame filter press.
Everyone. Today, we will learn about the structure and working principle of the plate and frame filter press. The plate and frame filter press is a filtration device used for solid-liquid separation and is widely applied in industries such as pharmaceuticals, chemicals, food and beverage, water treatment, brewing, dyeing, and environmental protection.
First, structure of the plate and frame filter press. The plate and frame filter press primarily consists of multiple sets of alternately arranged filter plates and filter frames stacked together to form filtration chambers. The surface of the filter plates has grooves, with protruding areas used to support the filter cloth. The corners of the filter frames and filter plates have through holes, which form complete channels when assembled, allowing the introduction of slurry, wash water, and the discharge of filtrate. Both sides of the plates and frames have handles that rest on the crossbeam, and the plates and frames are pressed together by a tightening device. The filter cloth between the plates and frames acts as a sealing gasket, and a feed pump is used to push the slurry into the filtration chambers. Second, working process of the plate and frame filter press. The feed pump forces the slurry into the filtration chambers, where filter cake forms on the filter cloth until the chambers are completely filled. The filtrate passes through the filter cloth and flows along the grooves of the filter plates to the corner channels of the plates and frames, where it is collected and discharged. After filtration is complete, clean water can be introduced to wash the filter cake. Following washing, compressed air may sometimes be introduced to remove any remaining wash liquid. The filter press is then opened to remove the filter cake and clean the filter cloth. The plates and frames are re-tightened to begin the next working cycle. Third, working principle of the plate and frame filter press. The mixed liquid flows through the filter cloth, with solids retained on the filter cloth, where they gradually accumulate to form a filter cake. The liquid portion permeates through the filter cloth to become clarified liquid free of solids. As the filtration process proceeds, cake filtration begins. The heat thickness of the filter cake gradually increases, causing greater filtration resistance. The longer the filtration time, the higher the separation efficiency.
Well, everyone, this concludes the structure and working principle of the plate and frame filter press. Does everyone understand the mechanism?
Candle filters are continuous devices that achieve full automation with the help of PLC control. They are composed of a container filter element, a PLC control system, and auxiliary system, such as drainage and purging. Please watch the candle filter video to understand its working principle.
A candle filter is an enclosed, multi-cartridge filtration system with automatic control, consisting of a pressure vessel, sintered metal powder filter elements, and an automated control system. Due to its easy maintenance and reusable filter elements, candle filters are widely used in the petrochemical industry. The slurry requiring solid-liquid separation is pumped from the storage tank into the candle filter. During the initial operation phase, the filter must undergo a degassing process and establish a stable filter cake layer to achieve the desired filtration precision. Therefore, the non-compliant filtrate produced at the startup stage must be recirculated back to the slurry tank for reprocessing. The solid particles in the slurry are retained on the outer surface of the filter element, forming a filter cake layer, while the clarified liquid free of solid particles permeates through the filter element from the outer wall to the inner wall, entering the hollow core of the filter element. As the filter cake layer builds up, the filtration precision is significantly enhanced. At this stage, the qualified clarified liquid ceases to be recirculated to the slurry tank and is instead discharged to the product storage tank. However, as the total volume of filtered slurry increases, the thickness of the filter cake layer gradually grows, leading to a corresponding rise in the total pressure drop across the filter element. When the total pressure drop reaches the preset value, the differential pressure transmitter on the candle filter sends a signal to the automatic control system. Subsequently, compressed gas is introduced into the filter elements to backflush and dislodge the filter cake, initiating the cake discharge process. Upon completion of the sludge discharge, the automatic control system reactivates the candle filter, commencing a new filtration cycle.
Class summary. Today we learned the classification of chemical machinery, became familiar with various typical chemical equipment, such as electric motors and gearboxes, pumps and compressors, and learned about their structures, working principles, and application scenarios. I hope that after class, you will combine what you have learned today by observing chemical equipment in daily life, training labs, or factories to deepen your understanding of these concepts. Next class, we will study the identification of chemical pipelines and valves, so please preview in advance.